Guys, today we're gonna do the possible rational zeros test or theorem. It says for each polynomial function, find the rational zeros and then the other zeros, that is solve f of x equals 0. And then part B says factor f of x into linear factors. Okay, so what does the rational zeros theorem say? It says, well, let a sub 3 equals the largest coefficient. Not the largest coefficient, but what I mean is the degree of the polynomial is the largest exponent of x. Therefore, a sub 3, 3 here is the exponent of x to the 3. And then a sub 3 is going to be the coefficient of x cubed, which is 3. Okay? This is the coefficient, this is the exponent. Now, a sub 0 is this number right here, okay? In this case is 5. Is the only number that has no x, okay? Now, what does the theorem say? Well, let P be all the factors of a sub 0, meaning plus or minus 1, plus or minus 5. And let Q be all the possible factors of 3. In this case, plus or minus 1, plus or minus 3. Then the theorem states that we need to have P divided by Q. Therefore, we're going to take each element of P and divide it by each element of Q. So for example, plus or minus 1 divided by plus or minus 1 is just plus or minus 1. Plus or minus 5 divided by plus or minus 1 is just plus or minus 5. And then plus or minus 1 divided by plus or minus 3 is plus or minus 1/3. And then 5 plus or minus 5 divided by plus or minus 3 is plus or minus 5/3. Okay? Now the theorem says if this polynomial has any rational zeros, it must be inside this list, all of them. Now, notice that it doesn't say that it's going to have a rational zero. Okay? So therefore, this is not an existence theorem. It's just saying if there is one, if there is a possibility of one, then the division of all, the list of all these rational numbers are all the possibilities for which these zeros are for this function. Now, in order to determine if these are actual zeros, we'll have to use synthetic division because it's the fastest way to find if a number is 0 or not. So for example, now notice also that it doesn't mean that the 1 is always going to work. Okay, you need to find them. Now I do know the answer, so I'm just going to do one example of where it doesn't work, and then I'll give you the 0 myself. Yeah, so let's say we're dividing by 1 using synthetic division. Let me go up. Okay, so let's write all the coefficients of the function. So 3, -1, -15, and 5. Okay, so we lower the 3. 1 times 3 is 3. We add -1 plus 3 is 2. 1 times 2 is 2. We add -15 plus 2 is -13. 1 times -13 is -13. And then -13 plus 5 is, I actually have to do it old school. Useless. Okay, so 5 plus 5 is 10 plus 3 is 6, 7, 8. So negative 8. Okay. Now, what is this negative 8? This negative 8 is the remainder. Okay. And the remainder's zeros test allows me to determine that the value at 1 is negative 8. But I'm looking for 0, not negative 8. So we have to keep trying. Now, like I said, I'm going to do 1/3. Okay. So you got 3, negative 1, negative 15, and 5. Lower the 3. 1/3 times 3 is 1. Negative 1 plus 1 is 0. 1/3 times 0 is 0. Negative 15 plus 0 is negative 15. 1/3 times negative 15 is negative 5. And 5 minus 5 is 0. Okay? So we found a 0. And that helps us for the solution of this function. Now, I'm going to factorize f of x using this new 0. So f of x equals 3x cubed minus x squared minus 15x plus 5. Now this is going to be, this is going to be equal to, well, x minus the 0 that we just found, which was 1/3, times the new polynomial that we've just found, which is 3x squared plus 0x minus 15. Okay? Now notice that 3x squared minus 15 can be factored using the solution method. Okay? So therefore, if 3x squared is a factor, that means that 3x squared minus 15 equals 0. Okay? It means that 3x squared equals 15. You divide by 3, you get x squared equals 5. Now that means that x equals plus or minus radical 5. Okay? That means that either x is radical 5 or x is negative radical 5. Now, in order to factorize this polynomial, I'm going to write x minus 1/3, x minus radical 5, and x minus minus, which makes plus radical 5. And that will be the solution. Now, if you want to write the solution set, it's going to be 1/3 radical 5, negative radical 5. Okay? Now let's do a longer one, a bigger polynomial, degree 4. Okay? Same method. I'm not going to repeat myself, but I'm going to choose a different color. So again, a sub 4 in this case is the coefficient 5, right? And a sub 0 is negative 4. Now p is all the factors of negative 4, which are plus or minus 1, plus or minus 2, plus or minus 4. Q are all the factors of 5, which are plus or minus 1, plus or minus 5. And then p divided by q, it's going to be all the positive combinations between p and q dividing these factors between these factors. Okay? So there's plus or minus 1, plus or minus 2, plus or minus 4, all of them divided by 1. Now you have plus or minus 1/5, plus or minus 2/5, and plus or minus 4/5. Okay? Which is 4. I did it backwards, clearly. It's, no, I'm good. Back it up. Okay, so it's all the possible solutions for this function. Now, You have to check all of them, okay? For this one, I'm going to choose 1 for my division. And then I'm going to write all the coefficients. So 5, negative 4, 19, minus 16, minus 4. Okay? So we lower the 5. 1 times 5 is 5. Negative 4 plus 5 is 1. 1 times 1 is 1. 19 times 1 is 19 plus 1 is 20. 1 times 20 is 20. 20 minus 16 is 4. 1 times 4 is 4. And we have left 0. Okay? In this example, 1 is actually a factor of this polynomial. So I'm going to write f of x equals x minus 1, this one right here, right? The one that gave us 0, and the new polynomial, 5x cubed plus x squared plus 20x plus 4. Okay? Now notice that this is not a quadratic equation. Okay? That means we can't use any other methods we've learned in class, so we will have to divide this polynomial once again by any of the list that we got from P over Q. Okay? Now, since I already know the answer, I'm going to jump to my next 0. So I'm going to try negative 1/2. Oops, not 1/2. Negative 1/2, 1/5. And then now I'm going to divide this polynomial here. So 5, 1, 20, and 4. So we lower the 5. Negative 1/5 times 5 is negative 1. 1 plus negative 1 is 0. Negative 1/5 times 0 is negative, 0. 20 plus 0 is 20. Negative 1/5 times 20 is negative 4. 4 plus negative 4 is 0. Okay, so now we're going to rewrite f of x with the next factor, x minus 1 times, remember if this is negative and the factorization is positive, so x plus 1/5, and then times 5x squared plus 20. Okay. Now we can solve for 5x squared plus 20 just like the previous example. So 5x squared plus 20 equals 0. 5x squared equals negative 20. Divide by 5. We get x squared equals negative 4. Which means that x is plus or minus radical negative 4, which is plus or minus I radical 4, which is plus or minus 2i. Okay, remember I is the square root of negative 1. That's why we had to change it to I, the imaginary number. So now the final factorization for this polynomial is x minus 1 times x plus 1/5 times x minus 2i times x plus 2i. And that will be your answer. Now for our last example, it's going to be one with fractions, because I love fractions. Okay, so you have same deal, nothing has changed. A sub 5 equals 1/3. A sub, oops, not 5. Man, that's what happens when you make videos at 1:30 in the morning. A sub 3 equals 1/3, and a sub 0 equals 1/6. Okay. So P is all the factors of 1/6. So plus or minus 1, plus or minus 1/2, plus or minus 1/3, and plus or minus 1/6. Okay. Now for for Q, you have plus or minus 1, and plus or minus 1/3. Yeah? So now we have to divide these numbers, P over Q. So it's going to be plus or minus 1, plus or minus 1/2, plus or minus 1/3, and plus or minus 1/6. But now it's also plus or minus 1/3, which is the reciprocal of 1/3, which is 3. And then plus or minus 1/2 divided by plus or minus 1/3 is going to be 3 plus or minus 3/2. This one is just 1, and then this one is plus or minus 2. 1/6 divided by 1/3. Wait, is that correct? It's 1/6 divided by 1/3. 1/6 times 3 over 1. Oh, it's 1/2. So that's wrong. And then 1/2 plus or minus 1. Let me double check all of these. 1/2 over 1/3. 1/2 times 3 over 1, which is 3/2. So it's plus or minus 3/2. We got that. And then plus or minus. So we don't get the plus or minus 3. Okay. Let's continue. So again, this is the fractions. Now, again, since I already know the answer, I'm going to check 1/2. So 1/2 inside the box, okay? And then the coefficients. So 1/3 minus 1/2 minus 1/6 plus 1/6, okay? So we lower the 1/3. 1/2 times 1/3 is 1/6, right? How do you multiply fractions straight across? Negative 1/2 plus 1/6, you need a common denominator of 6, so 3 over 3. So negative 3 plus 1 is negative 2/6, which is 1/3. 1/2 times negative 1/3 is negative 1/6 again. Negative 1/6 times plus negative 1/6 is negative 2 over 6. 1/2 times negative 2 over 6 is negative 1/6. And then this becomes 0. Pretty messy. Again, check your computations, verify everything is correct. Now, we're going to factor f of x. So 1/3 x cubed minus 1/2 x squared minus 1/6 x plus 1/6. We're going to factor that into x minus the 0, which is 1/2, times the new coefficient, the new polynomial, so 1/3 x squared minus 1/3 x minus 2/6, which is 1/3. Okay. Now, to simplify this one, we will need to use the quadratic equation. But first, I'm going to factor all these 1/3s out all the way to the front. So this is 1/3 times x minus 1/2 times x squared minus x minus 1. And notice that the 1/3 distributes back and you get this, okay? Now, a very common mistake when I ask my students to factor 1/3 is that they will put it in both spaces. They will put it in front and in the middle. And the reason that's incorrect is because the middle one will multiply 1/3 and get 1/9. Okay, so you wouldn't put it there, you would put it just in the front. Now, let's solve this one. We need the quadratic equation, so negative b, in this case negative 1, plus or minus the square root of negative 1 squared minus 4ac over 2 times 1. So this becomes 1 plus or minus square root of 1 plus 4 over 2, which is 1 plus or minus square root of 5 over 2. That means that you either have 1 plus radical 5 over 2 or 1 minus radical 5 over 2. So on the factorization here, you get 1/3, might need a little more space, times x minus 1/2 times x minus parentheses 1 plus radical 5 over 2 times x minus parentheses 1 minus radical 5 over 2 parentheses. Okay, now if you want to finish the simplification, you get 1/3 times x minus 1/2 times x minus 1 minus radical 5 over 2. Notice how the negative 1 here distributes the 1 and the radical 5 to get negative 1 minus radical 2 and x minus 1 plus radical 5 over 2. Okay? Now, this could be misleading, so I'm going to write everything in the same denominator. So x minus 1/2. The 2 can be multiplied by x, so 2x minus 1 minus radical 5 over 2, and 2x minus 1 plus radical 5 over 2. Okay? Notice that the 1/2 can be pulled in front. So 1/3 times 1/2 times 1/2 times x minus 1/2 times 2x minus 1 minus radical 5, 2x minus 1 plus radical 5. Let me fix that. I don't like it. Now, for my students, this right here will be the last step on the test, but I'm just showing you like how much we can get this simplified. Okay, so in this case it will be 3 times 4 is 12, x minus 1/2 times 2x minus 1 minus radical 5, and 2x minus 1 plus radical 5. And if you want to keep simplifying even further, you can factorize the 1/2 here. Okay, so 2x minus 1, so 1 over 12 times 1/2 times 2x minus 1 times 2x minus 1 minus radical 5 times 2x minus 1 plus radical 5. Okay, and then this one can be just turned into 24. Okay, and that will be all for this video. If you like the video, subscribe to Mr. Bonet, like the video, and I hope it was educational and you were able to understand. Thank you.